Did you know? The cornea is one of the most metabolically active tissues in your entire body. Yet it has absolutely no blood vessels. So how does it survive? How does it get its energy? And what happens when that energy supply fails? Stay with me for this comprehensive masterclass. Welcome back to Ophthalmology Made Easy. I'm Dr. Prabha. Today we are covering part 2 of our series, Corneal Metabolism. If you have not watched part 1 on corneal transparency, please watch that first. We are going to dive deep into energy production, so ensure you have your notes ready. Before we talk about how the cornea gets its energy, let us understand why it needs so much energy in the first place. The cornea needs energy for 3 main functions. Take a moment to prepare your notes and titles. Get your pens ready. Function number 1, maintaining transparency. The corneal endothelium works like a pump, continuously removing excess fluid from the stroma. This pump needs constant energy, constant ATP. Without it, the pump fails and the cornea becomes opaque. Precision is key here. The endothelium is the metabolic engine of the cornea. Function number 2, epithelial maintenance. The epithelium regenerates every 7 to 10 days. This constant turnover requires significant energy. Function number 3, wound healing. When injured, demand increases dramatically for cell migration and repair. All of this depends on metabolic pathways we will cover in the next section. To recap, Section 1. The cornea consumes energy for pump function, constant epithelial turnover, and the emergency demand of wound healing. These are the 3 fundamental reasons why it is so metabolically active. Ensure you have these 3 points noted down. The cornea is always consuming energy, even when you're sleeping. Now, where does this energy come from? The primary fuel for corneal metabolism is glucose. And glucose reaches the cornea from 3 distinct sources. Let's look at the primary one first. It is the most frequent exam point in clinical physiology. Source number 1, aqueous humor. This is the most important source of glucose for the cornea. It bathes the posterior surface and provides glucose directly to the endothelium and stroma. Remember, aqueous is number 1. This is a common postgraduate viva point. Source number 2, limbal blood vessels. The peripheral cornea receives glucose from these capillaries, but central cornea has no limbal supply. Source number 3, tear film. It provides a small amount of glucose to the epithelium, but this is minimal compared to aqueous. Note this distribution. It is important to understand the diffusion gradient. Glucose concentration is highest in the aqueous humor and lowest in the tears. Therefore, the primary direction of flow is from posterior to anterior. This gradient is the engine of nutrient supply. Write this down in your diagrams. Aqueous is the high pressure source for glucose. Example. Number 1. The most important source of glucose to the cornea is the aqueous humor. This is a frequently asked question in DNB, MS, and DOMS examinations. Mark this as essential for your postgraduate viva preparation. It is the lifeblood of the cornea. Aqueous is always the answer. Now that we have glucose, how does the cornea use it to produce energy? This brings us to the metabolic pathways. The cornea uses glucose through 3 distinct metabolic pathways. Each has a specific role and specific efficiency. Let's examine the major one first. It produces the most ATP molecules. Pathway number 1, aerobic glycolysis. This is the major pathway, accounting for 85% of glucose metabolism. In the presence of oxygen, glucose is broken down completely to produce 36 to 38 molecules of ATP. This is highly efficient energy production for the cornea. Ensure you note that 85% figure. Let's look at the yield. From a single glucose molecule, the aerobic pathway extracts up to 38 molecules of energy. This massive yield is what allows the energy-hungry endothelium to function every second of the day. Take a moment to note these values. The endothelium primarily uses this aerobic pathway because it has the highest energy demand in the entire cornea. It needs that maximum ATP yield to keep the pump running and maintain transparency. Link the pump to aerobic metabolism in your final notes. This is a favorite postgraduate theory topic for examiners. Pathway number 2, anaerobic glycolysis. When oxygen is limited, the cornea shifts here. Glucose is broken down without oxygen, producing only 2 molecules of ATP. Much less efficient. But the byproduct is the key, lactic acid. Note this clinical shift and its immediate impact on stromal pH. It leads to acidosis. Lactic acid accumulates in the stroma, causing corneal acidosis and eventually corneal edema. This is exactly what happens with contact lens overwear. The lens reduces oxygen, the cornea shifts to anaerobic metabolism, and you see a red, painful eye in your clinic. Pathophysiology in action. Copy this clinical flow. Pathway number 3, hexose monophosphate, shunt, or the pentose phosphate pathway. This accounts for about 35% of glucose metabolism. It produces NADPH, which is critical for maintaining glutathione levels to protect against oxidative damage. It's the cornea's antioxidant shield. Write this down. Example number 2. The hexose monophosphate shunt produces NADPH, which maintains glutathione levels to protect the cornea from oxidative damage. This is very high yield for your examinations. Memorize this sequence for your theory papers. It's a favorite MCQ topic, know it well. HMP is for defense. HMP. Here is a summary table for your master notes. Pathway efficiency ranges from 38 ATP down to just 2, with the HMP shunt providing critical antioxidant support. Compare these pathways carefully. It helps you understand why oxygen is so vital for clarity. This table is a goldmine for exams. I'll leave it up for a moment. Now let us talk about the second most important fuel. Oxygen. The cornea requires a constant supply for aerobic metabolism. Oxygen reaches the cornea from 3 sources, depending on whether your eyes are open or closed. This is a classic distinction in corneal physiology. Let's dive into the details. Copy the next source header. Source number 1, atmospheric oxygen. This is the most important source of oxygen for the open eye. Oxygen from the air dissolves in the tear film and diffuses directly into the corneal epithelium. This is the primary daytime supply. Note the diffusion path. Take down the value. It's about 155 millimeters of mercury. Diffusion is the key mechanism. Source number 2, aqueous humor. When the eye is closed, atmospheric oxygen is no longer available. Now the cornea depends on oxygen dissolved in aqueous humor. This is why oxygen tension drops during sleep, making overnight contact lens wear very high risk. Oxygen death starts here at night. Aqueous is the silent savior. Source number 3, limbal blood vessels. These supply oxygen only to the peripheral cornea. The central cornea again depends entirely on the atmosphere and the aqueous humor. This explains why the central cornea is most vulnerable to hypoxic stress. Write this anatomical fact down. Central center is at risk. Mark this. Let's look at the numbers. In the open eye, corneal oxygen tension is about 155 millimeters. But when you close your eyes, this drops significantly to just 55 millimeters. And here is MCQ trap number 2. Limbal vessels contribute 0 oxygen to the central cornea. It's a very common exam trap. Write these values down. They are high yield. Example number 3. For the open eye, The most important oxygen source is the atmosphere. For the closed eye, it is the aqueous humor. This extremely high-yield MCQ appears repeatedly in DNB and MS exams. Commit this comparison to memory for your finals. It's a standard repeat question. Don't get these mixed up. Copy it one last time. Note the sources. Here is a clinical comparison for your notes. Lens overwear causes acute lactic acid buildup, while Fuchs is a chronic pump failure that peaks under sleep hypoxia. Understanding these mechanisms helps you differentiate them in your clinical exams and on the wards. Take a moment to copy this differential table. It is very helpful for your clinical case discussions. Scenario 2. Fuchs dystrophy morning blur. During sleep, eyes are closed and atmospheric oxygen is unavailable. The endothelial pump, already weak in Fuchs, fails further under hypoxic stress. Edema worsens overnight, causing morning blurring that improves as you open your eyes and evaporation resumes. Vision is a circadian rhythm here. Highlight this link. Finish your notes. Ensure you have the mechanism. Let us finish with rapid-fire MCQs. MCQ number 1. Most important source of glucose to cornea. Answer: aqueous humor. MCQ number 2. Most important source of oxygen to open eye cornea. Answer: atmosphere. Quick check of your notes. Ensure you have these right before we move to part 2. You're doing great. Stay focused. Write fast. Review your answers. MCQ 3. Most important oxygen source to closed eye? Answer: aqueous humor. MCQ 4. Which pathway produces NADPH? Answer: HMP shunt. MCQ 5. Which layer has highest energy requirement? Answer: endothelium. These are your exam essentials. Commit these to memory. Ensure your notes are complete. You're ready for the finals. Good luck. Stay sharp. Finish your MCQ list. To summarize, the cornea gets glucose from aqueous limbal vessels and tears. It metabolizes it via aerobic, anaerobic, and HMP pathways. It gets oxygen from the atmosphere when open and aqueous when closed. Failure leads to edema and opacity. Take a final note of this comprehensive summary. It's the core of corneal life. Review this often. Memorize the numbers. This is the master summary. If you found this video helpful, please subscribe to Ophthalmology Made Easy. Like this video and share it with your fellow aspirants. Drop a comment on what topic you want next. See you in part 3, corneal wound healing. Goodbye for now and keep learning. Take care. See you in the next class. And as always, stay focused. Study hard. Keep learning. Stay curious. Goodbye. Keep making notes and see you in the next lecture. Keep learning. Stay sharp. Goodbye for now.